going to focus on the forest rather than clean technology or agriculture in this presentation, but I wanted to just take you through some of the basic points in carbon accounting that are important to remember as you want to develop projects. I do a lot of this with First Nations in BC in particular, and have done 2 or 3 projects a year since about 2003. And so many First Nations communities are trying to build capacity and understanding of this topic area. I'll see now if I can advance the slides. I don't seem to be able to advance the slides.
Siri, let's have you just click anywhere on the slide and then use the spacebar key.
Yeah. Okay. It's now working. I tried that before. Okay. So here's an overview of my presentation. I just wanted to highlight what I think the problem is for Canada around greenhouse gases and emissions, why the forests are an important role in that, show you how scientists break down then this discussion around carbon so that you have an overview of that, and then talk about how we project into the future. So we refer to this as modeling, and some key components of that are baseline and additionality, and I'll try and explain that. And then I'll just finish off my presentation with talking about the range of project types that are out there being considered for carbon financing at the moment. Once I finish this presentation, Shawn will take over then and talk more about financial markets and emissions trading. Okay, so this graph that you see is old, but it does depict the problem that Canada did commit at one point to reducing its greenhouse gas emissions by 6% below the level we had in 1990. We can see at the moment that at the minimum we are about 29% plus 6%. If you add that together, it's 35% above where we said we would be when we first signed on to Kyoto. So this is a disturbing trend. It means, in a sense, that as our economy has grown, we really haven't done much about managing our greenhouse gases. If you look at the next slide, you'll see that it breaks down by sector. This is Environment Canada data, where those emissions have increased between 1990 and 2010. And you can see that, of course, fossil fuel production has increased by 64% since 1990, and waste by 48% and so on. So you can see that clearly there's a problem, but the good news, I guess, is that we do have data to pinpoint where the biggest problems are so that we can then try and find some solutions. So let's shift now that we know we have a problem, to where one part of the solution is, and that's in the forest. And this diagram from the BC Ministry of Forests just tries to summarize the different what we call sources and sinks of carbon. And you can see in the diagram that it's a dynamic process where we are required, if we're going to actually manage carbon, to keep track of the carbon cycle. And this is just a forest sector carbon flow, where you can see that trees store lots of carbon, but there's lots of carbon in the soil. There's carbon in the coarse woody debris as it lies on the ground, minor vegetation, and so on. But we have to also keep track of our harvested wood products, our use of wood in bioenergy, and the way that wood products go into landfills, and so on. So it's a very complex process, and this is what probably attracts academics to it, is trying to figure out how we're going to map all these dynamic processes within a forest context. So moving to the next slide, we see that at a minimum what we have to do in the forest is we have to track what we call carbon pools. And so those main pools are the above and below ground biomass, as indicated on the right-hand side. That's the slide, the litter, and the soil organic matter. And so all of that data has to be compiled for essentially every single tree. And so you can imagine that this is a challenge because we have lots of species and we have lots of trees. But fortunately, we have lots of people who have built tools over the last 20, 25 years in order to try and figure out an efficient accounting system or process to keep track of that data. So the next slide, what I wanted to do here is emphasize the relative importance of the forests in comparison to all of our greenhouse gas emissions within Canada. So you'll see on the right-hand side of the slide that fossil fuel emissions in this schematic, and I'm not arguing that the numbers are perfect or correct, in fact they're dated, but was around 200 megatons of carbon per year as an emissions factor for Canada. You can see that the cycling of carbon by the growing of trees and then the loss of trees to fire, insect, and disease is almost a 15 times higher number in terms of, so annually we can say that there is far more impact from the cycle dynamics within the forest than there is from all industrial emissions. And I think most people underestimate, have underestimated this, and but it becomes then certainly a strong argument for including the forests in any kind of dialogue about how we reduce greenhouse gas emissions. The other number on the far left of your slide is 300,000 megatons of carbon. That, again, is a number 1,500 times more than the annual emissions. So you can see that the amount of carbon stored in forest and agricultural carbon pools is enormous. And these are clearly our estimates, but I think we have to put the discussion on how we manage greenhouse gases in this context. So I'm just going to go back. For some reason, I'm not seeing the slide about how much carbon is in wood. So something happened in the transfer, I guess, of the slides. But the main point of this slide was to point out that basically half of the wood fiber in a tree, given the wood density of the tree, you would say that basically half of the tree volume is carbon. So that means that a cubic meter of wood is probably equal to a ton of carbon dioxide, CO2. And so this gives you a sense of the magnitude and how we can go through the forest and measure the forest as a carbon sink. The next slide, what I'm trying to do is to demonstrate that once we come up with and decide on how to measure all that carbon in all the carbon pools, we have to be able to forecast into the future and to add up all the different stand types and forest types right across the country in order to come up with something credible. And so what we use are models. And so these models have been under development for the last 25 years. And the neat thing about them is, one, is that they're linked. In this case, forecast is linked to ecological processes within the forest. And the other kinds of models are linked to how we manage the forest, and in particular, how we harvest timber and try to come up with management plans and annual allowable cuts. So the nice thing is we have found ways to be able to report on carbon in an efficient manner that links with our existing efforts to try and manage for sustainable